Okay, welcome to the reteach for test 5 on forms of linear equations. We're just going to go through these questions here and try to see if we can't figure these problems out. Okay, so question 1, which equation represents the line that passes through the point 4, -2 with a slope of 1/2? Okay, so we need to remember that point slope form, which is what these equations are written in, they're all in point slope form. So in order to write this equation, we need to know what point slope form is. Excuse me. Okay, so the point slope form is y minus y1 equals m times x minus x1, where m is the slope of the line and x1 and y1 are a point that the line goes through. So in order to write the equation in point slope form, we want to plug in the -2 for the y and the 4 for the x. Okay, and then what we're going to want to do is simplify the y minus the -2. We can go ahead and simplify that y plus 2 times 4 times 4x minus 4. Okay, meaning the answer there for this question is B. Okay, then for question number 2, it says given f of x equals x and h of x equals f of x minus 3, how does h of x compare to f of x? So what's happening here is that the h of x equation is really the equation x minus 3, because if we substitute x in for f of x, then this equation for h of x would just be the equation x is minus 3. And what this minus 3 is going to do, if we take the x of the original equation and we subtract 3 from it, that will shift the graph of f of x equal to x downward 3 units. So I know that we weren't allowed to use calculators on this question, but Desmos would have been a good, had you had that option, Desmos would have been a good, good to use there. Question 3, how does the graph of g of x equal to 2 times f of x compare with the linear parent function f of x equals x? So again, by the substitution of x in for f of x, since that's what f of x is equal to, then g of x is the equation y equals 2x. Excuse me. And when you compare that, the graph of that equation to the graph of that f of x equals x equation, you would see that this equation g of x equals 2x is steeper than the parent function f of x equals x. So question 3, the answer there should have also been B. Okay, question 4. The amount of pressure in a car tire is given by P of x is equal to 34 minus x. So remember, anytime there's not a variable in front of or a number in front of a variable, then that number would be then a 1. So that equation we're looking at really could be thought of as P of x equals 34 minus 1x, where P is the pressure in pounds per square inch, that's PSI, pounds per square inch, and that's just generally how tire pressure is measured, and x is the number of months since the tire was filled. Describe what this function represents. Okay, so since P of x is the amount of pressure, P is the amount of pressure in the tire, then the initial tire pressure would have been that 34 pounds per square inch. Remember, the slope of a line, which is the coefficient of x in this types of equation, is -1, and that's the rate of change. In other words, the amount of air pressure in the tire is decreasing by 1 pound per square inch each month. And therefore, the answer to question 4 should have been C. Okay, and number 5. Which line contains the point 1, -2 and -3, 2? Okay, so this one we are just going to do with Desmos, okay? So I'm going to, just to make sure that we get some practice using Desmos to help us answer questions, then let's use Desmos on this question. So I'm going to type in the original equation here, or the equation, or the, excuse me, the first answer choice, y equals x plus 1. Okay? There's the that line. I'm also going to type in the two given points. 1, negative 2. So nice thing about Desmos is we can just type in a point and it will graph it for us. And the second point is negative 3, comma 2. And then I just want to verify, does that line go through those 2 points? Okay? And it does not. Therefore, I know A is not the correct answer to this problem. And then I can try answer choice B, which is negative x, y equals negative x plus 1. So y equals negative x plus 1. And you can see that that line is not going through the 2 points. So it cannot be the correct answer. Okay, answer choice C for this problem is y equals negative x minus 1. Y equals negative x minus 1. And boom, there it is. You can see that the line is going through the 2 points, 1 comma negative 2 and negative 3 comma 2. So that does verify that the correct answer choice for C, for 5, is answer choice C. Okay? So we could do 6 in a similar way, but I'm going to show you how we do this one without a calculator. Okay, so and I'm going to do this with slope-intercept form. So being that the slope of this line needs to be 2/3, then we know m in y equals mx plus b needs to be a 2/3. Now then what we need to know is what b needs to be, the y-intercept, in order for the line to go through the point 6, negative 5. So what we can do is plug in a negative 5 for the y, plug in a 6 for the x, because that is the x coordinate of that point, and solve for b. Okay? So 6 times 2/3, that'd be 4. Okay, subtract 4 on both sides to cancel out the positive 4. And negative 5 minus 4 will give us a b value of negative 9. So the equation, that is, got a slope of 2/3 and goes to the point 6, negative 5, would be y equals 2/3 x minus 9. So A was the answer choice we needed to go with for number 6. Okay, which equation represents the line? The line that represents the linear parent function after a positive vertical shift of 4 units. Okay, so back to Desmos here, and remember that the linear parent function is f of x equals x, or y equals x. Okay? Now then, in order to shift that down, what is it, 3 units? Positive vertical shift. So we want to shift up 4 units. So to shift that parent function up 4 units, we would need to add 4 to it. You see that equation x plus 4 is a vertical shift of y equals x in the positive direction. So the answer choice we wanted to go with there was answer choice D. Okay? Question number 8. A linear parent function is given with intercept shown in the table. Write an equation of the line that passes through these points. Okay, so let me use Desmos once again on this one. That should be an easy way to approach this, or easier way to approach this. So I want to check answer choice A, which is y equals x minus 5. Y equals x minus 5. And we can see here that it has an x intercept, or excuse me, a y intercept of 0, negative 5, a x-intercept of 5, 0, and that's exactly what the x-intercepts given in the table are. So the answer choice there for question number 8 is A. Okay, up to problem number 9. Which equation best represents the line graph below? Okay, so what we can do here is we can use the 2 points that they have put on the line, and we can use those 2 points to count from one point to the other to determine the slope. So starting from this point here, I would need to count down 1, 2, 3, 4, 5, 6, 7 units to get down to this other point here. And then from there, and so I went down, so I call that a -7 there. And then from there, it's over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's over 14. Okay, so it's looks like that's not going to be accurate to what our answer choices are. So let me recount this and reconsider this. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that would be 8 over 14. Now I did have to count down, so that's going to be -8, and then counting to the right is positive movement, so that would be positive 14. That would then reduce to -4 over 7. And then we can also see here that this does have a y-intercept down here at -9. Or I guess that'd be negative. It would have to be a -5 there. That's interesting. Okay, so based on the slope, the only possible answer, and where the noticing that the y-intercept is negative, then answer choice C has to be correct. Of course, you could have used your calculator to graph each one of these equations and find out which one looks like the line that's given. Okay, it has the same look to it. Okay, and then question number 10. The water level of a river is 34 feet and is receding, which means it's decreasing at a rate of 0.5 foot per day. Write an equation that represents the water level, W, after D days. In how many days will the water level be? 26 feet. So it starts out at 34 feet. Okay, so we can say W is equal to 34 feet as its starting height, and then it's decreasing at a rate of 0.5 foot per day, so we would want to use that as our rate of change value, in other words, sort of the slope, and then D is the day, so that would need to be multiplied by the amount of water it's losing per day. And then switching those two terms around, we could write that as negative 0.5 D plus 34. If you notice on this equation, all the equations were different. There was no answer that had the same equation. So basically, by finding this equation, we have determined the answer. Now then, we could verify that by using Desmos or a calculator and plugging in 16 for D and seeing what the water level says it would be. But when D is a 16, when you multiply that by the -0.5, that'd be a -8, and -8 plus 34 is 26. So that does, in fact, work out there. All right. And then going into the free response portion of the test. Mr. Suarez drains the water in his pool at a rate of 600 gallons per hour. After 12 hours of draining his pool, he has 8,000 gallons to go. For question 1, it says there, write an equation in point-slope form that describes the number of gallons of water left in his pool, y, after emptying the pool for x hours. Okay, so we want to write an equation in point-slope form, so we can go ahead and start by writing that. Y minus y1 equals m times x minus x1. All right, so what we need to do to write an equation in point-slope form is plug in a number for the slope, plug in an x-coordinate of a point and a y-coordinate of the point that this line will go through. Well, they tell us that x is the hours, and they say here that at 12 hours, he has 8,000 gallons to go, and y is the number of gallons of water. So by telling us that at 12 hours, he has 8,000 gallons to go, they're giving us a point that this line needs to go through, that point being the point 12, 8,000. Now then, they tell us that it's also losing, or he's draining his pool, then that's losing 600, or it's draining at a rate of 600 gallons per hour. So that means the slope, the rate of change is always a per or each amount. Okay, so that per word right there, that really is indicating that this 600 number is representing the slope. However, because it is draining at 600 gallons per hour, then that number does need to be actually written as a negative 600. So by plugging in these numbers into this equation, we come up with the equation y minus 8,000, that's the y-coordinate of the point, equals negative 600 times x minus 12. Okay? How much water does Mr. Suarez's pool hold, and how long does it take him to completely drain the pool? So there'd be a number of ways you could kind of approach this problem. But if it drained in 12 hours, if it drained 8,000 gallons, then that meant that it would have had been draining for, or it had drained, let's see here, let's actually just solve the equation for y, because by solving the equation for y, we can determine what this value would be. Okay? So we're going to take the negative 600 and distribute it. Okay, so multiply by the x and multiply by the negative 12. So we get y minus 8,000 equals negative 600 x plus, because I'm multiplying a negative 600 times a negative 12 when I distribute the negative 600 into the negative 12, so that makes that a plus, 7,200. Okay, by adding 8,000 to both sides, this equation could be written as y equals negative 600x plus 15,200. So that 15,200, that's the amount of water in the pool at hour 0. That's the y-intercept. And so that would be the amount of water that it would hold. If we would then, to answer the second part of this, we can take that 15,200, divide it by the rate that it's draining at, which is 600 gallons per minute, and figure out that it's going to take a total of 25.3 hours, or 25 1/3 hours, to drain the pool completely, meaning 25 hours and 30 minutes. Okay. Second way you could have determined that is by dividing the let's see, it's got 8,000 gallons still to go after 12 hours, where how much water has drained in 12 hours? Well, by multiplying the 600 times the 12, we can see that it has drained after 12 hours 7,200 gallons. Well, it has 8,000 gallons to go, so again we could add the 7,200 and the 8,000 to get that 15,200. Now then, when we add in the SPA that holds the additional 3,000 gallons, we could write this equation in a number of ways. Being that in question 2, I went ahead and solved that equation for y, the easiest thing to do is just rewrite that equation, but add 3,000 gallons to the y-intercept, and meaning that it would start out with 18,200 gallons to go. All right, compare their slopes and intercepts. Their slopes are the same. They're both negative 600. The y-intercept of 18,200 is larger than the y-intercept in equation 1 of 15,200. Okay? Then the x-intercept in equation 2 is 5 is larger, let me just say it this way, larger at 30.3 than the x-intercept in equation 1 of 25.3. Okay? And this can all be verified through Desmos. Okay, I can go to Desmos and type in these two equations. Okay, and I can even type it in with Desmos in point slope form. So if we never changed the equation to slope intercept form, then that would be fine. Okay. And then the second equation is y equals negative 600x plus 18,200. Now then, I need to then set up a window so I can see the x and the y-intercept. Okay, there's the x-intercepts. And it looks like this line's vertical, but in fact it's not vertical. The reason why it looks vertical is that these values along the y-axis are so big. The y values in this equation, starting out, are very large numbers. Okay, so I'm just trying to set a window here where I can see what the y-intercept is. And it takes a little bit of work here to get it set up right. Just trying to pinch the screen. Okay, and so that gives us a pretty good window there. So we can see here, this is the equation 1, the original equation. It has a y-intercept of 15,200. The second one has a y-intercept of 18,200. And then the x-intercepts, which represent how many hours it's going to take to completely drain the pools, are 25.33 for the original equation and 30.33 for the transformed equation. Okay, so that's how we can compare those slopes, or at least get the values that we would need in order to compare those slopes. Okay. All right, so next, compare their domains. Okay, so this is continuous variables, okay? And you don't absolutely have to state their domains in order to compare them, but the domain of equation 1 is X is, so this is how many hours is it, can the pool be drained for? Okay, not to completely drain. Just how many hours can it drain? Okay, well, it can drain for no hours at all. Okay, the pool does not have to be drained. Okay, and for equation 1, the maximum number of hours it can drain is 25.3 hours. Okay, 25 1/3. Equation 2, and the reason why I write it like that is because, again, this variable is continuous. We can drain the pool for an hour and 2 minutes, an hour and 3 minutes. We can even drain it for an hour, say, or 5 hours and 25 minutes and 20 seconds. We can drain it for 13 hours and 30 seconds. So all these values in between 0 and 25.3 really are valid values for this variable to be. And in those situations, we do want to state a domain in terms of an inequality. Also remember X, and I guess I really should be using H here. No, it's X and Y, isn't it? Okay, so sorry, yeah, that was right. Okay, but for equation 2, it can drain for up to 30 1/3 hours before it's empty, so it can't really drain any longer than that because there's no water to drain. All right, so that being the case, we can then say the x-intercept in equation, or not intercept, sorry, the domain in equation 2, the domain in equation 2 increases to a higher value. In equation 2 increases to a larger value. Okay? The ranges. Well, the range is how much water can be in the pool. And there could be no water in the pool for equation 1, or there can be a maximum amount of water in the pool of 15,200 gallons. Okay? And for equation 2, it can drain, it can have no water in the pool, or it can have a maximum amount of 18,200 gallons. Okay? So we can say that the range of equation 2 increases to a larger number than in equation 1. Okay. So, 2 ways that you could have made sure that you have gotten credit for the reteach part of retaking this test. First way is to have come in and listen to this and gone through this with your test with you, or take notes on this and then show that to me, and then you can take the retest after that. Thank you very much, and have a good day.